Hello everyone, welcome back to my channel. So in this video we'll see an example on electric field intensity due to sheet of charge. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get notifications from my channel. Right, in this problem he has given there is a finite sheet of charge for which x extends between 0 and 1 and also y extending from 0 to 1 on z is equal to 0 plane. That is, the sheet of charge is extending in the z plane, which has charge density of this rho s is equal to xy into x square plus y square plus 25 whole to the power of 3 by 2. And he has asked you to find the total charge, electric field at some point, and the force experienced by 1 nanocoulomb at the same point. Right? So how to solve this? So first problem, what is the total charge? Q is equal to integral s rho s ds. Okay, so what x is equal to 0 to 1, because z is equal to 0 plane, then what will be rho s value? So rho s value will be rho s into dx dy. Rho s is equal to rho s into dx dy. So x limits are from 0 to 1 and y limits are from 0 to 1. So that I will take y is equal to 0 to 1. Xy rho s is xy into x square plus y square plus 25 whole to the power of 3 by 2 dx dy. Okay, so okay, so this is the value. Right, so if you take y outside, so integral y is equal to 0 to 1 y dy. If you take outside integral x is equal to 0 to 1 x into x square plus y square plus 25 whole to the power of 3 by 2 dx. Okay, so in the second integration, in this integration, let x square plus y square plus 25 is equal to t. So then 2x dx, integrating with respect to x, 2x dx is equal to dt. Okay, so x dx is equal to dt by 2. Right, so limits also changes. When x is equal to 0, then t limits are y square plus 25, because when you substitute x is equal to 0 here, so you'll get y square plus 25. When x is equal to 1, then t limit is y square plus 26. So y square plus 25 plus 1 is y square plus 26. So when x is equal to 0 to 1, t extends from y square plus 25 to y square plus 26. So therefore q is equal to integral y is equal to 0 to 1 y into dy, as it is I am writing this integral. X in the place of this integral in terms of x is converted into integral in terms of t. So t x is equal to 0 corresponds to y square plus 25 and this corresponds to y square plus 26. So this x into dx can be written as dt by 2. So this total term x square plus y square plus 25 is t, so this becomes t power 3 by 2. So 1 by 2 is a constant, you can write it outside. Integral y is equal to 0 to 1 y dy into, so t power 3 by 2 becomes integral t power 3 by 2 is t power 5 by 2 by 5 by 2. Limits are from y square plus 25 to y square plus 26. Okay, so 1 by 2 I have written outside. T power 3 by 2 dt is t power 5 by 2 by 5 by 2, and I have substituted the limits. So it will be 1 by 2 integral y is equal to 0 to 1 y dy. Okay, so this 5 by 2 if you write outside, it will become 2 by 5 into 2 by 5 I will write outside. Okay, 2 by 5 into 1 by 2 y dy into, so this becomes y square plus 26 whole to the power of 5 by 2 minus y square plus 25 whole to the power of 5 by 2. Okay, so this 2 and 2 gets cancelled off, so 1 by 5 integral y is equal to 0 to 1. So I'm multiplying this y with this, so it will become y into y square plus 26 whole to the power of 5 by 2, right, dy. So 1 by 5 I'm taking it as common. I'm splitting it into two integrals. Y is equal to 0 to 1 y into y square plus 25 whole to the power of 5 by 2 dy. So in the first integral I'm taking y square plus 26. Y square plus 26 is equal to some variable t, and in the second integral I am taking y square plus 25 is equal to some other integral k. So this is 2y dy is equal to dt, 2y dy is equal to dk. Okay, so when y is equal to 0, t is equal to 26. When y is equal to 1, t is equal to 27. Similarly, when y is equal to 0, t is equal to 25, and when y is equal to 1, t is equal to 26. Right? So how will be the two integrals? 1 by 5 integral. So y is equal to 0 to 1. So when y is equal to 0 to 1, t tends to 26 to 27. So limits changes 26 to 27. Right? So y into dy is dt by 2. Okay. So y into dy is dt by 2. Right, so dt by 2 into y square plus 26. Y square plus 26 is t power 5 by 2. Okay, minus integral. So y is equal to 0 to 1. Y is equal to 0 to, when y is equal to 0 to 1, t tends to 25 to 26. 25 to 26. This is again dk by 2. Dk by 2. Y dy is equal to dk by 2. Right, so y square plus 25 is k power 5 by 2. Okay, so this now 1 by 5 into, so dt by 2, so 1 by 2 is common in both, so I'm multiplying here, so I'm writing here 1 by 10 directly. Okay, so this is t power 5 by 2 dt. T power 5 by 2 dt is t power 7 by 2 by 7 by 2. Limits are from 26 to 27, minus this is also k power 7 by 2. K power 7 by 2 by 7 by 2. Limits are from 25 to 26. So 7 by 2 is common in both. So if it goes to numerator, it is 2 by 7. So 1 by 10 multiplied by 2 by 7 into, I am substituting the limits. So 25 whole to the 27, sorry. 27 whole to the power of 7 by 2 minus 26 whole to the power of 7 by 2. So upper limit minus lower limit. 27 whole to the power of 7 by 2 minus 26 whole to the power of 7 by 2. This 7 by 2 I have written outside. Right? So minus sign is there. So I am taking minus sign. Upper limit is 26 whole to the power of 7 by 2 minus of minus. So minus of minus. So plus 25 whole to the power of 7 by 2. This is just integration. Okay, 2 5. So 1 by 35 into 27 whole to the power of 7 by 2 plus 25 whole to the power of 7 by 2 minus 2 into 26 whole to the power of 7 by 2. Okay, so solve it using your calci. So you'll get around 33.15 nanocoulomb. Sorry, this is nanocoulomb per meter square. Rho s is in nanocoulomb per meter square. So you'll get the charge also in nanocoulomb. Okay, so I forgot this. Please write this also, nanocoulomb per meter square. This rho s units are nanocoulomb per meter square. So everywhere it is multiplied by 10 to the power of 9. So you'll get in nanocoulomb. Okay, so this is how we can find the total charge of a given finite sheet. Okay, so let me take one more slide. I'll solve for the second and third problems. Okay, so the next question is this. Okay, so he has asked to find the electric field intensity at 0, 0, 5. Okay, so electric field intensity is given by integral S rho S ds by 4 pi epsilon naught r square into AR cap. So this is integral S rho S ds by 4 pi epsilon naught. So this is r bar divided by r again, so multiplied by r square, it becomes r cube, right? So what is r bar? R bar is equal to r minus r dash. So r is the point of interest where you are going to find the electric field intensity. So here we are going to find at 0, 0, 5. So it is 0, 0, 5 minus r dash. R dash is the point where this sheet of charge is extended. So now it is extended in z is equal to 0 plane, so it will be x, y, 0. Okay, any point on z is equal to 0 plane is of type x is equal to x, y, 0. So this will be minus x minus y, 5. So if you write in vector form, it will be minus x ax cap minus y ay cap plus 5a z cap. So r, which is the modulus value, is given by root of x square plus y square plus 25. Okay, so if you substitute here, so and what is ds value? Ds is equal to dx dy, because z is equal to 0 is the plane here. So ds is equal to dx and dy, dx into dy. So x is equal to 0 to 1, limits I am substituting here because it is given, and y is equal to 0 to 1. Rho s value is xy into x square plus y square plus z square whole to the power of 3 by 2 into r bar. R bar is minus x ax cap minus y ay cap plus 5 az cap divided by 4 pi epsilon naught into r cube. R cube is x square plus y square plus z square whole to the power of 3 by 2. So this and this gets cancelled off. Okay, so this is nano coulomb per meter square, so it will be multiplied by 10 to the power of minus 9. This 1 by 4 pi epsilon naught is a constant you can write outside the integration. So 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 into 10 to the power of minus 9, as it is I am writing here. Okay, so 1 by 4 pi epsilon naught I have taken outside and implemented its value. So okay, integral x is equal to 0 to 1, integral y is equal to 0 to 1, xy into minus x. So minus x square y, okay, minus x square y dx dy into ax cap. I am separating this. Okay, dx dy into, so here you will have dx, here you will have dx into dy also. Okay, dx into dy into ax cap, right, plus this minus y into xy. So minus y into xy is x is equal to 0 to 1, y is equal to 0 to 1 minus xy square dx dy into ay cap plus integral x is equal to 0 to 1, integral y is equal to 0 to 1 xy into 5. So this will be 5xy dx dy into az cap. Okay, so 10 to the power of 9, 10 to the power of 9 gets cancelled off. Okay, so 9 into, see the first integral, so integral 0 to 1, so this is x square minus x square dx, integral 0 to 1 y dy, so this total into ax cap, plus 9 is multiplied with everything, right? So 9 into see the second integral, integral 0 to 1 with respect to x I am writing first, so minus x dx integral 0 to 1 y square dy into ay cap plus 9 into integral 0 to, so 5 is common, so 5 is constant, you can write outside 5 into 9, right? So for the third integral 0 to 1 x dx, integral 0 to 1 y dy into az cap. So this will be 9 into, so integral of minus x square is minus x cube by 3, so if you substitute the limits it will be minus 1 by 3, so into, so integral of y dy is y square by 2, and if you substitute the limits 0 to 1, so it will be 1 by 2, minus 1 by 3 into 1 by 2 ax cap, okay, plus 9 into, so integral of minus x is minus x square by 2, if you substitute the limits it will be minus 1 by 2, so this is minus 1 by 2, and integral of y square by 2 limits integration is y cube by 3, if you substitute the limits from 0 to 1 it will be 1 by 3, so I'll writing directly 1 by 3 into ay cap, plus this will be 45, 9 5s are 45, integral 0 to 1 x dx is x square by 2, limits are from 0 to 1, so it will be 1 by 2, into integral y dy also it will be 1 by 2 az cap, okay. So if you just substitute this values, so 3 1s are 3 3s are, okay, minus 3 by 2 is minus 1.5, minus 1.5 ax cap, minus 1.5 ay cap, plus 11.25 az cap volt per meter, okay. So this is how we can find the electric field intensity due to sheet of charge for a given rho s value, okay. So in the third problem he has asked you to find the force at the same value at a 0, 0, 5 experienced by the given charge of q is equal to minus 1 millicoulomb, okay. So we know that f bar is equal to q into e bar, f bar is equal to q into e bar. So e bar at 0, 0, 5 is obtained in the second question, so this is the e bar, so I'm writing directly, so minus 1 into 10 to the power of minus 3, okay, q value is minus 1 millicoulomb into minus 1.5 ax cap minus 1.5 ay cap plus 11.25 az cap. So final answer will be, so the force will be 1.5 ax cap, right, so minus into minus plus 1.5 ax cap plus 1.5 ay cap, right, minus 11.25 az cap, okay. So this 10 to the power minus 3 I am taking it as millinewtons, in the units I am writing it as millinewtons, okay. So this is how we can solve a given problem based on sheet charge, okay. You can find the total charge, you can find the electric field intensity, you can find the force also, okay.